Okay, welcome to this playlist. This is going to be a collection of questions relating to structure and bonding and intermolecular forces. So this question was set as homework, and I'm going to talk you through the best way to answer these questions. So question 1, this is an example of a multiple choice question. Chemists determine some properties of two substances, C and D, and the results are shown in the table below. So we've got differences in melting point, conductivity and solubility. These are the three properties you were taught about in your lessons relating to your different types of structure. All right. Which row correctly identifies the bonding and the structure in C and D? So you've got to start thinking back to those lessons, thinking about what different structures you have looked at. So we've got the options: giant ionic, giant covalent, giant metallic, or simple covalent. Those were your four options of the different structures. So thinking about the different properties of those chemicals, you then have to piece together what's going on. So if we take straight away melting points, we've got melting points both in the multiple hundreds. So straight away you can start to rule out any simple covalent molecules because they're going to have very, very low melting and boiling points because we're only overcoming intermolecular forces with the simple covalent structures. And actually, if you look at the answers again, you can see straight away we've got options between only giant ionic and giant metallic. So they're narrowing it down for you straight away. Electrical conductivity. So C is conductive when solid, but not when let's stick with C. It's conductive when solid and conductive when molten, but not soluble in water. So if we think about that, out of these options here, metals conduct when they're solid and they conduct when they're molten because metals have delocalized electrons and they will be delocalized whether the metal is solid or not. And metals don't usually dissolve in water. Metals can react in water. Think about your alkali metals, for example, but they're not commonly going to dissolve in water. Otherwise, all our metallic structures would disappear when it rains, and then it would be in a hell of a state, wouldn't we? So compound C is going to be a metal. Compound D, melting point of 801, so high melting point, not conductive when solid, but is when molten. And the only structure you've come across that does this would be your giant ionic lattice. We know it's not conductive when it's solid because the ionic lattice is fixed. The ions are fixed in position and the ions therefore cannot move. As soon as you melt or dissolve an ionic lattice, the ions become mobile. So the substance becomes conductive and therefore soluble in water. Ionic substances are soluble in water because water is polar. Ionic substances contain oppositely charged ions, so this is definitely telling me that this substance is going to be an ionic substance. So options, option A is C is ionic, D is metallic. Well, we've got the other way around, so that's wrong. They're definitely both not ionic. They're definitely not both metallic. Therefore, it's D. Compound C is a giant metallic structure. Compound D is a giant ionic lattice.